Thank you, Simon, for that warm introduction. It's an honor to be here in front of the RASC Calgary Centre and those who made the journey downtown here in Calgary, and those who are watching maybe from home, enjoying a lovely evening watching this lecture. Joel and I are excited to share this presentation, which is took us, I'll be honest, several long days of assembling all the data. There is so much and it's constantly changing. But anyways, it's something that we will enjoy here, and we are anxious to share it with you here today. So let's begin. And we would like to dedicate this lecture to Phil Johnson. And as it's been known, he was known as Uncle Phil to many of us here. Phil was a long-time member of the RAC Calgary Centre, and he helped so many members build their first telescope. Some even won awards for their construction efforts. And I'm sure many of them pointed it at the moon, if not all of them. And that's the subject of tonight's presentation. So our thoughts and prayers go out to the family, and we will dearly miss Phil. We also like to dedicate this presentation to someone else who recently passed away. His name is James Burke, and he was the first manager of the Ranger Lunar program at the Jet Propulsion Laboratory, a very historic figure in lunar exploration. So today, we're going to talk about the moon, and I think all of us here have watched the moon rise, whether you've just been standing out in the yard or looking through an eyepiece in your telescope, and it's just absolutely stunning. I mean, I'm sure we've all just enjoyed looking at those craters and mountains on the moon. But you know, before we could get there, we had to rely on the imagination and fantasies of science fiction writers. Like back in 1865, Jules Verne wrote his first book about, well, not his first book, but the book From Earth to the Moon, which he had his explorers get into a capsule in a cannon, which was located in Tampa, Florida, which is not too far from Cape Canaveral, and launch towards the moon. But he ended the book as they were leaving Earth's gravity and going towards the moon. And of course, all the audience, well, what happened to him? So he wrote a sequel 5 years later, Around the Moon. So we got to learn what happened to these explorers. There were some silent movies back in 1902 called A Trip to the Moon, once again using a cannon to launch the explorers to our closest celestial neighbor. And it was followed up with another movie, another silent movie, a German one, but this time they actually used a multi-stage rocket, not a cannon, and used a countdown, which was something we still use today. So some great history in the past. We relied on those imaginations. And this is a childhood favorite of mine. When I was a young lad growing up in North Winnipeg, went to a local movie theater called the Highland Theater, and there was this movie called First Men in the Moon. It was a British movie released in 1964. And there was one of the main characters' name was Joseph Cavor, and he invented this paste that he painted on this object that you see here that would repel gravity. So he had paste on it and it would repel gravity and took them to the moon. And of course, their adventures thereon. So, I mean, I've heard they've made a sequel in 2010 or something, but I've never seen it, and it's probably not as good as the original. Yeah. But one of the first movies, I think, that really epic movies is Stanley Kubrick's 2001: A Space Odyssey in 1968, before even Neil Armstrong and Buzz Aldrin landed on the moon. And it's been 50 years, over 50 years, since we've last walked on the moon's surface. There are no spinning space stations. We don't have a permanent moon base. We are still waiting for astronauts to go back to the moon. So how do we turn science fiction into reality? Well, I think it takes some visionaries, and I'll be turning the floor over to Joel here in a moment, but we need visionaries like Konstantin Tsiolkovsky, Robert Goddard, Wernher von Braun, who had visions of exploring the closest celestial neighbor and the planets not far away. So it took them to consider, how do we build rockets to take us there? And Joel will now take the floor and explain some of the early history. And believe me, we can't do all of it. We're going to hit highlights, but take it away, Joel.
Okay, the Soviet Union was the first country to actually get spacecraft to the moon. This was in the year 1959. Now, the first two, they're called Lunas. The first one missed, but the second Luna was the first artificial object from Earth to impact on the surface of the moon in September 1959. Luna 3 returned the first views of the moon's far side, which is really the first scientific return from the early lunar explorations. This was on October 7th, 1959. Now, one of the curious things about this project, but from the Soviets, is that they used special Kodak film that was recovered from spy balloons that had floated over the ocean and crashed in the Soviet Union, because the Soviet film stock was so inferior that they had to use this captured film from the Air Force Genetrix spy balloons. Now, NASA's first moon program was the Ranger program. They managed, after a number of tries, 3 impacts on the moon, which returned photographs. This is a sequence showing the final images before impact of Ranger 9 in 1965, impacting the crater Alphonsus. This was about the best we had until Apollo got to the moon with astronauts. Follow-ons by NASA, the Lunar Orbiter was a program, and self-explanatory. 5 probes orbited the moon to take photographs, very high-resolution photographs, to search out mostly for potential landing sites for the Apollo program. Lunar Orbiter also captured the first Earthrise picture of the moon and the Earth, not Apollo 8. And then many decades later, NASA scientists were able to reprocess the data, the raw data from the lunar orbiters, and they produced much higher resolution images. Here's another reprocessed image of the crater Copernicus. This was captured by one of the lunar orbiters, and one of the most spectacular pictures of the entire, the early lunar program. Now, the Soviets, again, were the first to land a soft land on the lunar surface. February 1966, this odd-looking contraption was landed on the moon by the Soviets. Here is one of the first set of panoramic images that it returned from the surface of the moon by a primitive facsimile system. NASA's lunar unpiloted robotic lunar landing program was Project Surveyor. 5 Surveyor spacecrafts managed to reach the surface of the moon and take survey pictures. Lunar Orbiter 3 managed to capture Surveyor 1 sitting on the surface of the ocean of storms. It soft landed on June the 2nd, 1966. This is an example of some of the imagery that was returned by Surveyor 1. This is a picture taken by Earthlight, which is the light from the sun reflected off of the Earth during the nighttime, and they took this low light level image. The surveyors actually took some remarkable pictures. The last surveyor of the program, Surveyor 7, landed just off the rim of the crater Tycho, which is actually a naked eye object on the moon. Surveyor 7 returned this picture of one of many looking toward the rim of crater Tycho. Now, the Soviet Union had follow-ons to the lunar program, and they landed 3 spacecraft on the moon, which launched back off the surface, bringing samples of the lunar regolith back to the Earth. They collected a grand total of 300 grams of material. The second program that the Soviets used, that was called a Lunar. These were actually quite sophisticated lunar rovers. They were an interesting array of cameras and scientific instruments. But one of the unknown uses of Lunar would have been to ferry around the Soviet cosmonaut had they ever landed on the moon, but they never did. Here we have some of the recent lunar programs, international programs. We have Japanese, We have Indian, Chinese, and then a couple of NASA orbiters illustrated here. But of course, the highlight of the lunar exploration so far was NASA's Apollo program. There were 6 successful lunar landings made, piloted by astronauts, and 1 was aborted, the famous Apollo 13 mission. Here we have the first lunar landing, of course, was Apollo 11 and on the Sea of Tranquility, the 20th of July, 1969. Here we have a picture taken from a camera up in the cabin of the lunar module, showing Buzz and Neil together on the surface. The first follow-on to Apollo 11 was Apollo 12. In November 1969, it reached the ocean of storms. This is one of my favorite photographs in the entire Apollo program. This is astronaut Pete Conrad backing down the ladder of the lunar module on his way to the surface of the ocean of storms. After that, after Apollo 13 was aborted, Apollo 14 landed at the same target from Morrow as Apollo 13 would have gone with Jim Lovell. This is Apollo 14's commander, Alan Shepard, who was America's first man in space. Apollo 15, one of the most spectacular of the final 3 missions, the J missions. Here's astronaut Jim Irwin on the edge of Hadley Rill. The most spectacular feature that I think that the Apollo astronauts visited during the program. Here's Apollo 15's lunar module in front of the Apennine Mountains out there in the background. And if you're wondering why the lunar module is crooked, it actually, one of the back landing legs landed in a pothole. And astronaut Irwin said they almost broke the gear. They were lucky, and it just managed to come in under the tilt, the allowed tilt of the lunar module, so that they could take off again. Following on Apollo 15 was Apollo 16. They visited the Cayley Plains, and here's a famous picture of astronaut John Young and his leaping salute in front of the lunar module in the American flag. Here's the Apollo 17's lunar module, it's called Challenger. This is early in EVA #1, and we see here Gene Cernan test driving the famous lunar rover. Here's a nice shot from the cabin of the Apollo 17 lunar module. The rovers were electric powered, almost like a Jeep, a little car for them, and it extended the range of the astronauts so that they can not only travel further than just in walking distance, they were also able to bring back an enormous amount of samples on each of the 3 EVAs on these extensive missions. Now this is here we have astronaut Gene Cernan. He was the last astronaut to walk on the moon. So now we go on to present day lunar exploration. Here we have this is the Lunar Reconnaissance Orbit. It was launched in 2009. It still orbits the moon today, and it's returning extreme high resolution pictures for scientists to study. Now, these are the 6 landing sites of the Apollo program. The lunar modules are all visible here. The tracks of the astronauts, either walking or driving in the rover. This is the proof that one of the proofs that the astronauts actually reached the moon, unless you believe that they're phony. Now, China has an extensive lunar program now. This is a video that they released of a Chang'e 4 landing of the spacecraft on the far side of the moon. This is January 2019. On the right here is the landing sequence that they used. Here we have the Chang'e 4. The landing platform is here on the left, and their little U2 rover is on the right. This is a very successful mission for the Chinese. Here's this is their first panorama taken from the far side of the moon after the spacecraft touched down in the Von Karman crater. This is near the moon's south pole in the Aitken Basin. And this is just to, illustrate where it landed on Carmen. The next phase of their program was a sample return mission in December 2020. They drilled into the surface, got samples of the regolith, and the return capsule came back to Earth on the 16th of December in 2020. They managed to bring back, I think, a little over a kilogram and a half of material, a little bit better than the Soviets managed. Okay, now we go get back to discussing sending humans back to the moon in the Artemis project. Here we have one of the logos. This is Artemis is the twin sister of Apollo. That's why they chose the name. Here we have NASA's mission statement for landing on the people on the moon. I won't read it here, but we'll see in a moment that it's maybe not a sure thing just yet. So why go back to the moon? Our closest celestial neighbor, of course, preserves a record of evidence of the origin of the Earth. This is very important. Don will touch on this in a moment. The early geological evolution of a terrestrial planet is revealed by the samples from the moon. And the inner solar system environment from billions of years ago can be deduced from the samples that have been brought back and will be brought back in future missions. And now I'll turn it over to Don. He'll talk about the scientific legacy.
Thanks, Joel.
of Apollo.
Okay. Okay, no worries. Thanks, Joel. Well, probably the most important legacy of the Apollo moon program is the moon rocks. I mean, they brought back 382 kilograms of rocks and regolith from the lunar surface, which the scientists have been studying for decades and have learned a lot. When I was in, it's not advancing. Sorry, that's okay. There we go. Good. When I was in university many lifetimes ago, I took a planetary geology course, and it was quite an early form of planetary geology. And I was presented 3 ideas on how the moon, they thought at the time, came to be. One was the sister theory that both the moon and the Earth accreted from the same kind of solar nebula and kind of formed together and became 2 worlds. The second one was called the fission theory or fission idea, that the Earth was spinning so fast that, the moon kind of got thrown out. And that explained, if you look here, that's the Pacific Ocean basin. This is before, plate tectonics is widely accepted. Yeah, I'm kind of old. But anyways, but we know that's not possible. I mean, plates are moving around. That's not where the moon came from. And the last idea was that the moon was a wandering planetoid that came really close to the Earth, and it was captured by Earth's gravity, but planetary orbital dynamics, it just doesn't happen. So okay, I'm not advancing, Simon. Should I just use? Okay. Should work. Okay, thanks. So all 3 of those ideas were wrong and proven wrong by the Apollo samples. When they brought the rocks back, they were of course studied, and they learned something very interesting. It's almost eerily interesting in that the oxygen isotope ratios, and this is like the flavor of oxygen on the moon, was almost identical to that on Earth, which is like, wow, how could that be possible? Because these are 2 separate bodies. Also, it was established just by the density, is that the moon has a very tiny iron core, much smaller than it should have for a world of that size. So how did that come to be? Well, the best hypothesis now is called the giant impact hypothesis, which goes way back to the early Earth, where it was just forming, and it was in a huge collision with a Mars-sized body. Now, it wasn't a dead-on, it was a glancing blow, affecting most of the crustal material, so not as much of our iron core, so just mostly crustal, lighter elements. So if we play this computer, this is one of the best computer simulations that I have seen, and it's fairly recent, showing a Mars-sized body colliding with the Earth, an early Earth. So, I mean, this is a catastrophic event that just, totally disrupted these worlds. And most of the material still falls back on the Earth, but the smaller amount of material that is out, from this collision becomes the moon. And because of Earth's much larger mass, it can actually give a little push to this smaller world, propelling it outwards to a wider and more stable orbit. This gives us a whole new idea or perspective on how moons might form around other planets in our solar system, and even planets around, or moons around exoplanets out there in our galaxy. So very interesting, and this is the latest from what we know. So these moon rocks are very valuable, and they're still being studied today. Now, it's not just the rocks that tell us the history, because we have plate tectonics, we have erosion. I mean, all our early history here on Earth has been eroded. So the moon does give us that look back to the past. But there's also something more. There was a mission called LCROSS, Lunar Crater Observation Sensing Satellite, back in 2009, about the same time that LRO was placed into orbit. And because some scientists thought, like all the Apollo moon landings occurred on the equator, very dry. There's not a lot of, any volatiles or water there. But scientists thought, well, the polar regions have some really deep craters. Could these craters contain water ice? Could there be water there, which is huge in terms of space exploration? So they devised this experiment to send the upper stage of a Centaur rocket colliding into, or impacting into this deep crater that's permanently shadowed, and to then send another spacecraft right behind it, LCROSS, to measure what's in the plume. Meanwhile, LRO, which Joel's been talking about, was in orbit looking at the whole scene. And it was discovered that just in the narrow window of that spacecraft going through the plume, there was at least 100 kilograms of water. Now, if you extrapolate that over the entire south and lunar poles regions, there's probably millions of kilograms of water ice in those deep craters, which again is huge for space exploration, because we could use water to drink, break it into oxygen to breathe, hydrogen for rocket fuel. It is huge. So again, why go back to the moon? Well, it's a great laboratory to test hardware. We want to go to Mars eventually. Let's test it on the moon, because that's a great, we're not far from Earth if something goes wrong. We can also learn how to live on another celestial body by mining that water and living off the land, just as our forefathers did when they moved to Canada here. And there's also political motives. When I was in Florida back in August of this year, I was almost shocked to hear NASA Administrator Bill Nelson say he's really worried about China reaching the moon first, the South Polar region. He's afraid that they might claim that water for themselves, similar to what they did in the South China Sea with the Spratly Islands. So he's really worrying, like he really wants to have the international, because not just the US, it's an international consortium that's going to the moon. And well, we'll see what happens. I mean, it's not going as smoothly as we'd like, but it is moving forward. As Joel said, in order to get back to the moon with humans, we need a new program, and it's called Artemis. And as was said, it's the twin sister to Apollo, and we need a new rocket. The Saturn V is gone, it's retired, it's in museums now. So we need a new rocket, and you need a new name. So something original like SLS, or Space Launch System. That's very original. And how big is it? Well, we probably remember the shuttle. It was launched up till about 2011. Unless you're 12 years old or less, you may not have remembered the shuttle. It's been retired that long. But the Space Launch System is nearly twice as tall as the space shuttle. It is big. And if you look at it, it's using a lot of the space shuttle elements. So let's go quickly through the elements of the Space Launch System. There's a massive core stage, just a big tank full of rocket fuel. And it has, rather than fueling the space shuttle as it did in the space shuttle program, they put 4 space shuttle main engines at the base of this core stage. They've been, souped up and been refurbished. And this whole tank or core stage was taken to Mississippi, to the Stennis Space Center, and tested for a full duration test called the green run, a full 500 seconds, and it worked fantastic. So that was good. The second item you need to launch on the moon, or launch a rocket to the moon, is you need more power. That core stage just isn't enough. So just like the shuttle, there are 2 solid rocket motors on the side. Now, these are 54 meters tall. They burn 5.5 tons of propellant every second, and each booster produces over 3 million pounds of thrust. Now, one of those segments looks like this. That's one of 5 segments. They're massive. These are really big segments. And this is a test viewed last summer, actually, in Utah. That's over 3 million pounds of thrust. I'm not going to play the full 2 minutes of that. Above the core stage and the solid rocket motors is the upper stage, or it's also known as the ICPS, or interim cryogenic propulsion stage. I like upper stage, or something like that. It's from the Delta IV rocket. So basically they just repurposed a stage from an existing rocket and place it on top of SLS, because this is the final push into Earth orbit. It's also reused or restarted to send the crew on to the moon as a translunar injection, and it can also carry a little bit of extra payload. Above that is the service module, which is built by the Europeans, so it's called the European Service Module, and it looks as the picture on the right here. On the left, because it's a little narrower than the actual diameter of the stage and the upper stage and the crew module, they have some aerodynamic panels that you can see on the far right-hand side, which are jettisoned after launch. So what does the European Space or Service Module do? It actually provides life support and thermal control for the crew, can perform mid-course corrections, slow the craft down, put it into lunar orbit, send the crew back home to Earth. And that main engine at the very end here, if you remember, the shuttle had 3 main engines and 2 what's called OMS engines, orbital maneuvering system engines. That's one of them. They've just repurposed some of the old shuttle engines. So Orion, you need a capsule, and they call it Orion. It's got extra radiation protection because you're going beyond Earth's protective magnetic field. It has a heavy-duty heat shield because you come back a lot hotter and faster than coming back from Earth orbit. For crew health, it has a galley, a toilet, an exercise area. So it's got the comforts to keep a crew healthy for a longer time in space, and of course, power propulsion on its own, and it's built to last. This is what the capsule looks like. It looks a bit, if you remember the Apollo program, it kind of looks like the Apollo capsule, just supersized for a crew of 4 rather than 3. This is some flight hardware that was reviewed in August. So on the top 2 panels are for the next Artemis mission. That's the capsule and the service module, all ready to go, just have to be stacked onto the rocket. Now for Artemis 3 and 4, the capsules are at the what's called the Armstrong Operations and Checkout Building in Florida. And this is what the pressure vessel, that's what the raw vessel looks like. So underneath that is this. That's the pressure vessel before they put all the protective paneling and the electronics inside for the control panels. That's what Orion looks like. Inside, you can see the panel. At the top left would be the commander, pilot on the right, and below would be 2 mission specialists. Now, Orion has flown before Artemis 1. In December of 2004, Orion was actually flown on what's called EFT-1, or Exploration Flight Test 1, that made 2 orbits around the Earth for about a 4.5-hour journey and re-entered the Earth's atmosphere and was recovered. So Orion was already in space once, and it just flew the second time with Artemis 1. This, you can actually see this capsule at the Kennedy Space Center at the Gateway exhibit. And something the shuttle never had was a way to save the crew in case of a catastrophic failure. So Apollo had an escape tower. Well, so does the space launch system. It's a protective cone that sits over top of the capsule with a tower with rockets that take the crew away in a very, like, they have 3 motors that go very quickly. And this is a test of a launch sequence. So imagine a rocket taking launching. There's a catastrophic failure. Well, the rockets fire and take the crew away. And then that capsule with the protective cone is jettisoned, and the crew will eventually land back on Earth with the parachutes deploying in the water. Okay, you got a rocket, you got an escape system, you got a capsule, you got everything you need, but how do you put it together? Some assembly is required, and you need a big building. So the Apollo Heritage Vehicle Assembly Building is where the rocket is stacked. And if you look inside, this is an absolutely cavernous building. It is massive. It's one of the largest buildings in the world by volume. And again, looking up, it's just like it's over 50 stories high. It is massive. You also need a launch pad. The shuttle launch pads are gone. Pad 39A and B have all been kind of stripped down, repurposed. 39A is being used by SpaceX. 39B is set up for the Artemis program. And this is the launch pad as seen back, not that long ago. And this is what it looks like. You have a 2-story mobile base here with a tower that extends up many floors. There's elevators that can take you to the top. And I might note that this platform, this mobile platform, sits on pylons. So how does this get to the launch pad? And I'll show you in a minute. This is my co-presenter here, Joel Powell, standing at the top. And if you look to the very bottom right-hand corner, you might see a little tracked vehicle there. Well, that's the massive crawler transporter. So this 2-story platform sits on these pylons. The transporter goes underneath, raises itself hydraulically, lifts the rocket, the platform, the tower, everything off the ground, and slowly at a unbelievable rate of 1 mile per hour will take that all to the launch pad. Now, that's me beside this massive, there's 8 tracks on this vehicle. Each one of those cleats is about 1 metric ton. Now, it's powered by these big diesel locomotive engines, and they make a lot of noise. So there's a Calgary connection. Those mufflers are built in Calgary, Alberta, Canada. So there you go. Yay, Calgary. Calgary helps get humans to the moon. There you go. This was the first rollout back in March, St. Patrick's Day, 2022. I had a camera just taking pictures on it. It was so large, it went out of my frame. It was massive. So I let it go by and got a photo here of it moving towards the Atlantic Ocean with the moon rising in the east. It was magical to watch this go by. And this is a picture I took from what's called the turnaround basin, getting a little bit of reflection in the water. So once at the launch pad for the first time, engineers had no idea, how do we fill this thing with rocket propellant? How do we get this thing ready for launch? Well, it was painful. They had trouble with hydrogen. They couldn't get a good seal. There was hydrogen leaking, which is bad, very explosive. They couldn't fill the tank fast enough. It seemed like there would be back pressure. So they had to learn how to go with a slow fill and then eventually get into a fast fill. Anyways, they had to roll it back, do repairs, and rolled it out a second time back in August of 2022. And this is a great fisheye shot as it's leaving the vehicle assembly building with all the work platforms visible as it heading out into darkness. And Joel happened to be there at the time and took this picture of it rolling out of the vehicle assembly building. And once at the launch pad, of course, they hook up all the umbilicals. And this photo is not to show you the bullnose umbilical connector. It's to show you the workers. Look at the guys with hard hats for scale. I mean, guys and gals. So, I mean, it's just amazing, the size, the scale of this rocket is truly amazing. And of course, you have to put the crew access arm in position and fill the capsule with some experiments. So they had one mannequin or figure called Moonikin, who was put into an old shuttle spacesuit and had some accelerometers and measuring devices on him. And there was also a very cool radiation experiment because our bodies are quite susceptible to radiation. So they had 2 figures heavily instrumented with radiation detectors, one with a vest and one without. This vest is called Astrorad, and it's a joint venture with Germany, Israel, and Lockheed Martin from America. So it's very interesting. I haven't heard the results, but I'm sure it worked because they use this vest of varying thickness. So where it covers vital organs, it's thicker. And it's a polymer filled with a substance rich in hydrogen, which of course can block radiation. This is what it looked like inside the cabin before launch. You've got the mannequin in the launch seat up there and the two astrorad experimental figures over below where the mission specialist would normally sit. And before launch, you got to close the hatch. So that's the Orion capsule hatch. And this is the second hatch, which is part of that escape system. And now a new launch date is set for November 16th, 2022, with the target well in sight. This is a stunning photograph taken from low Earth orbit, looking down at launch pad 39B with Artemis on the pad. So launch day occurs. Here we are. You know, it's in the middle of the night. Everyone's kind of tired, and everything is going absolutely perfectly. They've learned how to fill. They got good seals on the connectors to the rocket, to the umbilicals. They got the slow fill going. Then he started the fast fill. Everything was going perfectly. And then we hear there's a hydrogen leak. And we go, oh no, here we go. Here we go again. And it wasn't on the rocket. It was in the mobile base, that two-story platform at the bottom. Now, NASA was prepared for this. They sent out what's called a red team to head out to the launch pad. You know, this rocket is nearly full of fuel. It's quite a dangerous situation with their, you know, wrenches to tighten up these bolts, and they actually fixed it. It worked. Now, if you're older, and you might remember this, you know, we had a different vision in the press site of what we thought was really going on at the launch pad. This is how we thought the red team was working at the pad. If you're a Star Trek fan, you'll know the scene from Assignment Earth released in 1968. But in any event, at 1:47 in the morning, Artemis launches. SLS lifts off for the first time, and it was truly spectacular. I had a GoPro 5 with a timer on it that was set to record the launch. And you'll see the main engine start, and then when the solid rocket motors ignite, it's like an explosion. This is from just a couple hundred meters away. Here's the main engines starting up. Oh, my camera's shaking in the corner. That is 8.8 million pounds of thrust. This is also taken with a remote camera using a sound trigger, showing the power of this rocket. It is, you know, it's mind-boggling. This short video clip is also showing the liftoff, but from a different perspective. There's a camera on the side of the rocket looking down. You can see a bit of the orange core stage there. And when the sort of plume moves away, you'll see one of the solid rocket motors there on the side. So it's just a short clip showing the liftoff. The plume, there's no sound. Does a little rotation. And it literally lit up the Space Coast. It turned night into day. Truly magnificent. About 2 minutes into flight, the solid rocket motors are jettisoned. And shortly after that, the escape tower that I showed is jettisoned. They had a little peephole with a camera. So I'm just going to loop this. You'll see it launch a couple of times here. So this is the escape tower being jettisoned, revealing the capsule. So this is just looped a couple of times there. And this is another photo of what it looked like if you were just standing there at the press site looking at the launch. You'd see this magnificent rocket taking off with the moon in the distance as it arches towards the moon. It was, you know, a memory I'm sure Joel and I will never forget. But you can't help wonder, because of over 50 years earlier, Apollo 17 on a massive Saturn V rocket lifted off at night. And you wonder, like, we saw Artemis 1 or the first SLS flight, and you know what the comparison that was going through our minds, what it must have been like to see Apollo 17 on a Saturn V rocket lift off. So Apollo, like, this is Saturn V on the left, Artemis 1 on the right. And just another spectacular view of the night launch of the Saturn V Apollo 17 launch. So the mission, and again, just so we know, the Artemis 1 or SLS is about 15% more powerful than the Saturn V, just for if anyone's wondering what was bigger. The mission for Artemis 1 was to leave Earth orbit, make 2 orbits around the moon, and then head back to Earth. This is what it looked like in the cabin during flight. You can see Moonikin there watching the control panel quite well there. And here's Snoopy floating. Snoopy was the doll, the Stuffy was the 0G indicator to show when you're in low gravity. This is Artemis 1 passing the moon, looking at the far side of the moon. And this picture here is sort of a record for a human-rated craft, the most distance from our home, almost 500,000 kilometers when you think about it. And there were cameras on the tips of the solar panels looking back, so you could see the Orion capsule, the service module here with the Earth-Moon system in the background. And eventually, after 25 days or so, it starts heading back to Earth, re-enters the atmosphere at nearly 40,000 kilometers an hour, very fast. And it's, again, protective. Unlike Apollo, there's also protective shielding on the sides of the spacecraft. And here's splashdown on December 11th. Ryan, unlike the Apollo astronauts, which were picked up by baskets on helicopters, Orion was towed into the well deck of the USS Portland. So where it's brought in or towed in, doors are closed, drained, and then you can access the spacecraft that way. Well, I'm going to take a rest now and have Joel continue on with the exciting future. And I'll tell you, this slide deck has been changing almost weekly because there's so much going on. So take it away, Joel.
Future lunar exploration. Now, in the last 4 or 5 years, there's been a number of lunar landing attempts made by Israel, India, Japan, and in August, unfortunately for the Russians, I call it the litany of failures, because landing on the moon is hard. It's not easy. It's not. The Chinese actually had good success, but it's very difficult. So a month ago, the Indians' Chandrayaan-3 mission landed on the moon successfully. They're first. And they targeted the landing for near to the South Pole. The South Pole is a recurring theme in the lunar exploration in these days. Here's a little video of Chandrayaan-3's Pragyan rover driving off the ramp of the landing platform. This is a ISRO, the Indian Space Agency video. You see the little rover taking a pirouette, photographing the landing platform on the surface. Here's one of its pictures, the spacecraft sitting on the moon. This is actually that's the ramp that the rover came down, and that's why it looks lopsided. But it's a very interesting picture. Now, coming up in the next few years or so, several missions are underway or will be underway very shortly. JAXA, the Japanese Space Exploration Agency, launched this probe, the Smart Lander for investigating the moon, launched on the 7th of September. It's on the way, but it won't reach the moon until January or February next year. There's now NASA has some planned missions, or sponsoring missions anyway, like commercial companies. This is Intuitive Machines and Nova C. It's like a garbage can, but it's 4 meters tall, and the launch window for Nova C is November 15th to 20th this year, on a Falcon 9 rocket. Other probes to come. Robotic has built the Peregrine lunar lander and is scheduled to launch on ULA's brand new Vulcan rocket. They keep insisting on the 4th quarter of 2023. Well, remains to be seen. NASA is looking for private companies to provide supplies and ways of supplying and sending robotic scouts to the lunar South Pole region. One example is the Griffin lunar lander here carrying the Viper rover with a proposed launch date of November 2024. Here we have the Viper rover. It's going to look for volatile compounds from lunar ice on the lunar surface near the South Pole. And Canada is in the game. We have tentatively scheduled a lunar rover built in Canada, perhaps 2026, 2027. It's probably going to piggyback on a larger mission. Our space agency, our Canadian Space Agency, is testing various designs of lunar rovers. This model has a drilling assembly on the deck, although this is not likely to be included on our Canadian lunar rover. There will be a contest for the public to give it a name. So what is next for Artemis? And is Artemis 2? It's going to take a mission on another SLS rocket. It's actually less complex than an Artemis 1. There will be people on board for the first time. And oddly enough, it's only going to do a loop around the moon and come back. It's a little over 9-day mission. And there's going to be a Canadian astronaut aboard Artemis 2. Here we have Jeremy Hansen, Canadian astronaut, one of 4 astronauts. He's going to accompany Commander Reed Wiseman and 2 mission specialists in this mission to the moon. Here they are at the Kennedy Space Center in August, posing in front of their capsule. That's the Artemis 2 capsule. There's Jeremy proudly wearing a flag. These people will be the first humans to travel to the moon since December 1972, over half a century ago. Now, our Artemis 3 was scheduled to be the first landing attempt. But NASA needs a lunar lander because SpaceX has fallen way behind in their contracted development of the Starship and to produce a human landing system, a lunar lander. Now, where will Artemis 3 or 4 or even 5 land? Well, the lunar South Pole. The actual target is the crater Shackleton. And in a case of art imitating life, from the For All Mankind TV series has chosen to put their lunar base at the crater Shackleton. Now here we have a very cool video. This is the approach to the lunar South Pole, the Shackleton crater area, taken from the Lunar Reconnaissance Orbiter. The craters at the South Pole of the moon are mostly in shadow, permanently in shadow for billions of years, and they figure there's a lot of there's a lot of ice that formed over the millennia. Here's a close-up of Shackleton exactly at the South Pole of the moon, by the way. Here's some prime sites with measurements of lunar ice: Shoemaker, Sverdrup, and of course Shackleton. Here we have a little bit more detailed view of the landing target area near Shackleton for NASA's missions and probably for other countries. And this is an image of Shackleton derived from LRO data. Landing site 1 is toward the bottom here, and here's the permanently shadowed interior of Shackleton. And this is the exact location of the lunar South Pole. Here's an earlier NASA image, artist's concept of a lunar lander at Shackleton, which the shadowed area with the Earth peeking over the moon's limb. So if Artemis 3 is delayed, what exactly can NASA do around the moon while waiting for the lunar landing system to be developed? Well, the answer is a space station. called Lunar Gateway. It's being developed and it's probably under construction as we speak. There will be they will use a SpaceX Falcon Heavy rocket to launch most of the components. And it will be almost, well, like the ISS, various modules built by the ESA, Japan, and Canada. We will be contributing the third version of the Canadarm3 to the Gateway space station, which will be located around the moon. Right now, well, Northrop Grumman is developing the major habitation and logistics outpost modules, the power, holding the power and propulsion systems for the Gateway. The Gateway system is designed to move, unlike ISS, it can be moved around in various locations in lunar orbit. Now, how do you resupply the space station orbiting the moon? SpaceX has developed or is developing the Dragon XL resupply spacecraft, and it'll be launched off to the moon on a Falcon Heavy rocket when the Gateway space station is ready to go. Now, this is the Starship, the SpaceX Super Heavy booster. It's currently waiting for FAA approval for a second launch. And if you recall, a few months ago, the first launch of this giant rocket ended spectacularly badly. So we're waiting for that. Now, since SpaceX is so badly behind, not only are they behind in developing the human landing system, as they call it, they also have to learn some new techniques in Earth orbit. It's actually designed to, they dock 2 of these starships for refueling. They were going to, in order to get one of them to go to the moon, they're going to have extra fuel, just like, you know, the Air Force uses tanker aircraft to refuel Air Force missions. So as we are waiting for SpaceX to bring up the rear here, and developing the human landing system, eventually we will see human explorers return to the moon's surface and do their scientific work. Here is a NASA, call it a propaganda video, but it's kind of. And yes, that's William Shatner's voice.
Today, our calling to explore is even greater. To go farther, we must be able to sustain mission of greater distance and duration. We must use the resources to find our destination. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. Going to the moon to stay by 2024. This is how.
This all starts with the ability to get larger, heavier payloads off planet and beyond Earth's gravity.
For this, we design an entirely new rocket, a space launch system. SLS will be the most powerful rocket ever developed.
And with components in production
And more investment,
this system is capable of being the catalyst for deep space missions. We need a capsule that can support humans from launch through deep space and return safely back to Earth. For this, we built Orion.
this is NASA's next generation human space capsule. Using data from lunar orbits that continue to reveal its hazards and resources. We're currently developing an entirely new approach to landing and operating on the moon. Using our commercial partners to deliver science instruments and robotics to the surface, we're paving the way for human missions in 2024.
Our charge is to go quickly and steady to press our collective efforts forward with a fervor that will see us return to the moon in the manner that's 50 years ago.
The landers that are reusable, that can land anywhere on the lunar surface. The simplest way to do so is to give them a platform in orbit around the moon for which to transition.
An orbiting platform to host deep space experiments, The waypoint for indications. We call this lunar outpost gateway.
The beauty of the gateway is that it can be moved between orbits
It will balance between the Earth and Moon's gravity.
in a position that is ideal for launching even deeper space missions. In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted, purified with water, and separate an oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited to prepare us and propel us to Mars and beyond.
This is what we're building.
This is what we're training for.
This we can replicate throughout the solar system. This is the next chapter of human space exploration.
Humans are the most fragile element of this entire event, and yet we go forward to it. We go to the moon and on to Mars to seek knowledge and understanding and to share with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going. We are going.
We are
Going. We're going.
Hopefully these programs will serve as stepping stones to even further destinations in space, deep space, asteroids. And eventually, maybe in the next decade, humanity will head to the red planet, Mars.
Thanks, Joel. And yeah, this is the end of our presentation. We really have to thank the Calgary Public Library for hosting this event. Of course, the RSC Calgary Centre for inviting us to speak, starting off a brand new season of talks here at this great club. And of course, all of you for coming here this evening and tuning online. We also have to acknowledge all the government agencies that allowed us access to see this incredible hardware, also the private contractors who again have given us permission. And of course, our media sponsors, CBC for me and Spaceflight Magazine for Joel. And your two hosts here are very grateful for your time and attention, and we are now open for any comments or questions. Thank you very much.
All right, so if any of you have questions here, just raise your hand and I will also take questions online. So for those of you online, just use the Q&A function. Type in your question. I see there's a couple questions there already. Type in your question and we will ask Don and Joel your question for you and they will do their best to answer it. So we'll first start off with a question from online, and that question is, would the Lunar Gateway space station have a permanent astronaut presence?
Actually, I don't believe that it will. It's intended to be people, we'll say, as needed almost, and it will involve multiple launches of, say, SLS rockets or well, maybe Falcon Heavies to take people up there to do their work in concert with the planned Artemis missions.
Okay, question over there, yes.
Gateway actually was designed for permanent, but they rolled that back to the area. Like something like 4 or 5 weeks a year.
Yeah.
But no, my question though is, Gateway, the orbit is, they say it's L2 stabilized, but for the life of me, I can't figure out what that means. Because I look at the trajectory,
Yeah, it's in a stable position between the Earth and the Moon, highly elliptical. So that's, I mean, I'm not an orbital dynamics.
If anything, it looks like it might stabilize by L1.
Yeah.
The Lagrangian point between yours and the Moon.
Exactly.
But I can't even see that because it's got that 90-degree of a phase point, but it's actually gone down. It's not staying in European plane.
Right.
Oh, they probably used the onboard propulsion system to tweak the orbit.
Yeah.
Yeah, I think actually been using it in check.
Isn't there an unmanned craft in that orbit now that they've sent?
Yep, yep.
And if anybody knows what L2 stabilized means.
Any other questions or comments here this evening? Yes.
Are we gonna, so, is it true that we're gonna move to the moon?
Okay, the question is, are we going to move to the moon and Mars? And I think there will be some efforts. There will be eventually I mean, the whole idea of Artemis and Gateway is to make a more permanent presence on the moon. Will it be as 2001? Maybe not near term, but in the long term. I'm a big fan of the Expanse series, read all the books, and I hope we do move out to Moon and Mars and the asteroid belt in the future, but it will take time. You're at the right age though to be, walking on Mars. So great question. Thank you.
All right, we'll take another question online. What would astronauts be able to accomplish that could not be done by developing appropriate remote operated vehicles?
Well, Don here, he's a geologist. He could tell you that a machine is not going to do a good job as the human brain. Looking for samples, evaluate, just as they did at Apollo. There was a geologist on the final Apollo, the lunar landing, Harrison Schmitt. He was able to, to evaluate samples and what to take and what not. But they had such good training that most of the other astronauts were turned into pretty fair field geologists.
Yeah. I had a great interview with Dr. Stephen Squires, who was with the Mars opportunity and the rovers, Spirit and Opportunity, thanks Joel, that were roving on Mars, and what those rovers accomplished in a year or two, an astronaut can do like in a few days, because they can walk around, they can evaluate. So, I mean, it can be done slowly, but man, having someone with a human brain, proper training, will do a lot more work a lot faster. So, yeah. Alan.
Yeah, there was just some of the Artemis 2 crew were just in Canada, northern Canada, last month or so, doing the same kind of geology training, all that stuff.
Yeah.
But in the grand scheme of things, what's the future of the space station, the ISS? When is it supposed to be now decommissioned and keep getting extended? It plays no role in the moon mission.
Okay, just yesterday, NASA made a proposal or sent out a request for proposals for a deorbit system, a rocket engine system to be sent up to the ISS. Right now they're thinking 2030 that they will deorbit it and decommission it. There's already plans for commercial space stations, smaller ones, to do the work that they're doing up there now.
Plus, some commercial entities may want to take some of those modules and add it onto their space station if it's viable. So it's still unknown exactly, but whether it's deorbited or piece of it reused for commercial work is still in discussion.
Great. We'll take another one online. Are there any development activities underway at present for the proposed lunar base?
Lunar base, I'm not aware of anything. I mean, I know DARPA is looking at it right now as a 10-year plan. That's a defense agency in the US, but I know of no.
ESA has their village concept, but that, again, this is all, it may as well be science fiction. It's still in the early stages of planning.
And there's a place at NASA called Swamp Works. You've heard of Skunk Works for military type. Well, they have Swamp Works at Florida, and they are experimenting with using lunar regolith for 3D printing and just rovers to handle the dust situation. So, I mean, they're actively looking at ways to how do you build a habitat? I mean, taking concrete or steel or whatever is tough, but if you can use the lunar regolith, melt it, and use 3D printers to start building your habitats, it's fantastic. I mean, that's living off the land, just again, as our forefathers did, cutting down trees or digging holes in huts. Sod huts, yeah. Pardon me?
Abraham Lincoln.
Yeah, that's right. That's right.
Well, we have certain advantages in our day and age.
Yes.
Does the moon hold a part of holding Earth's atmosphere together?
Earth's atmosphere. I don't know if I can answer that one. Yeah, I mean, I can't answer that. I don't know.
There's very, imperceptible tides created by the moon, almost like the ocean, but it's not much of I don't believe it's much of a factor. I mean, it's been as far away as it is now for many billions of years.
They're moving away.
All right.
That's right.
Another question from online. This is for both of you.
Okay.
What first got you into this field? Did you ever consider being an astronaut as a child or as an adult or now? Question for both of you. Yeah.
Okay. So what got me turned on to space exploration was my mom and a great uncle. My mom woke me up to watch John Glenn lift off, and when I saw a rocket go, I said, "Oh, that's pretty cool." I don't think at the time I was the right age to becoming an astronaut. There were no Canadian astronauts at the time, so it was not even a thought in my mind. If I win the lottery, Simon, and can pay that ticket price to go to the moon, like out of whatever it is, $50 million. And if Marianne, my wife, would allow me, yeah, I'd go for the ride. But so I guess I would love to go, but I'm of that age now, probably getting too old. And Joel, what got you turned on?
Well, I got turned on by the 10th anniversary of Sputnik. There was fairly extensive coverage in what was really primary media in those days, the newspapers. And I started clipping things. I even made a display in my I think it was 5th grade class, and then started collecting this stuff. And of course, the real mission started with Apollo 7 to test the spacecraft. And then Apollo 8 went to the moon, and that just blew me away. So, and of course, Apollo 11, I remember vividly just watching the coverage, sweating, sweat dripping down my.
Oh, it's okay. Another time.
Any other questions?
Yes.
Which one use the geologist? Okay. Are you an exploration geologist?
I was. I'm retired now, but yes, I was.
Okay. How much geological potential does the moon have from an exploration geology point of view?
Can you repeat the question? Pardon me? Can you repeat the question?
Oh, yeah. So the question was, how much geologic potential? Like in what, in mining or what? Yeah. Again, I'm not a lunar geologist. I was a Western Canadian sedimentary basin geologist, but I right now, water is the big focus, and going to the poles, the South Pole in particular, as we've clearly shown here tonight, is the target. So, I mean, is there titanium? Is there iron? I mean, there's some of it on there, but is there helium? I mean, there's lots of elements that I'm sure we could try to harvest. Is it enough to make it viable? That's a really tough question right now. If you do the full cycle economics,
I mean, they haven't done enough sampling of anything.
Right. Exactly. Yeah. So yeah, we really don't know the exact numbers yet. Yes, Roland.
Maybe.
Yeah, sure. Add. Yes.
We know that a lot of the islands built smars. It's very likely close to the top of a large magnet chamber. And on Earth, we have to go back 2 billion years. We find what are called later igneous complexes. And they have a roof of this light mineral on top. If you go down into them, and we have the south of Montana and Earth, field, we have chromite and other minerals, and they're layered in igneous bodies. So hypothetically, you might be able to find something like that on the moon if it's been excavated enough by.
So Roland just provided an answer. There could be chromite in the highlands, I guess is.
Probably not, because the moon's crust probably formed as a static model rather than the years crust continues to get more. And so a lot of but you're talking about the bodies I'm talking about are all old. Yeah, but much
Pre-Cambrian. Archean.
But I was thinking about the Crete fish lake, which often has a lot of the rare elements in it that is a mantle series coming to the surface. And we see creep in several places on the moon, which is it's an acronym for passing marathon. Thank you. I was having problems showing them what the hell it gave us. Yeah, well, no, but yeah, is there a geologist in the house? I just think there has to be a reason for it, other than just, we went to tourism light, but that's pretty sketchy.
It's also a laboratory for testing hardware going to Mars. I mean, Mars is the big goal.
Except the problem is that the environment on the moon is so different than the environment on Mars that you really test in apples and oranges, so it is. But it's.
All right,
I'm not against it. I
oh.
just don't think that-
we'll take one online and then we'll take one from the crowd. So does NASA plan on doing research and or bringing any helium-3 for future nuclear fusion research?
Not that we know of. Yeah, that's a great question, but I don't know of that. Alan?
You mentioned the concern about from NASA about the Chinese claiming. Is there not a moon treaty that prevents that? Are the Chinese not signatories to that?
That's exactly right. You're talking about the Moon Treaty signed, I think, in 1967 at the United Nations. China was not a signatory.
So they shouldn't be concerned because they're not.
It's space wise.
Peter?
Just a little bit different, going back to Joel, your presentation with all those early landers and that I wasn't aware of that actually made it to the moon. But I remember reading that there's a lot of them when they were landing Apollo about how stable the moon was and whether they're going to sink into dust and everything else. Is that just a myth that didn't take into account that information that they gathered?
Yeah, it was in a kind of a canard. And Professor Gold came up with this idea that they would sink in and then the dust would be like bottomless nearly. But the early landing probes proved that the moon's surface was quite stable. Even those the impact probes, the Rangers, pretty well proved to the science. They convinced themselves that the surface was not dust, endless layers of dust. It was solid and stable.
It's another one of those myths that got destroyed with more evidence.
Yes, I would say so.
It's an idea.
All right, we'll take another one online. Is there any evidence of plate tectonics on the moon?
No,
No.
it's been shrinking. It's been cooling.
Venus.
Yeah, maybe Venus, but no.
Okay, another one online. For a university student or anyone looking to be involved with the space sector in any capacity, whether the grand dream of being an astronaut or working on the ground in the CSA, is there any insight or advice that you could provide?
Well, there are internships both offered by NASA, Canadian Space Agency. I'd just be going online, checking out when these applications are due. And yes, they take Canadian students. So does Americans, NASA. If you've got an interest in space exploration, and if you're in the field of engineering or hard, SpaceX, Blue Origin, all these companies are looking for new people. It is a growing industry right now.
Suggest you read Chris Hadfield's book. How about that?
Question?
I heard in one of the videos that part of the new stage started.
Yeah, okay, there is no dark side of the moon, but the permanently shadowed craters, those deep holes on the polar regions, they're dark all the time, but the moon there's always one half that has some light. So, I mean, dark side of the moon, I don't like to say that it's always the far side of the moon, not the dark side. The dark side gets sunlight just like the near side. It's Pink Floyd. Yeah. Peter?
What's the difference between the potential for water on the South Pole versus the North Pole?
The South Pole's just been better explored right now. It seems like it's better mapped. That's all I can tell you right now, unless anyone else has any more information on that. Yeah.
How mountain thingies on the moon going?
Okay, the mountains on the moon are usually rims of massive craters, big impact basins. So there was a big, say an asteroid impacting the moon, creating a big hole with a large rim around it. So those mountains are normally curved on the edge of large impact basins. Good question.
What about the mountains inside the craters? That's a fun one.
The central peaks up, the central uplift. Yeah, so
Yeah.
inside craters you
Yeah,
get,
that's
if they're big enough,
the
you'll get rebound. Yeah. Rock behaves kind of like a fluid when under high temperature and pressure.
Any other questions? Any other questions online? Please put into the Q&A. Any questions here? Yeah.
There are plans to take samples from the far side of the moon, and would there be any difference compared to the samples we have right now?
Yeah, that's a great.
Do you want to repeat the
Oh, yes.
question?
Yeah, so the question was, are there any missions right now planning to bring samples back from the far side of the moon? Sorry?
It's all good.
Yeah. Oh, okay, I pulled it.
Yeah, yeah,
That's all good. Did I unplug? So sorry. So the question was, are there any plans to return samples from the far side of the moon? Not yet that I'm aware of, but I'd love to know what the far side. The Chinese mission that's on the far side has indicated they have found something unusual or something more like different than what they found in years. I don't know what that is, but in any event, I'm hoping there'll be more releases, more science information released to explain what they found.
Questions? Perfect. All right. Well, thank you again, Dawn and Joel, for joining us here this evening, and for all of you joining online. Let's give them a round of applause. Thank you.